Oh, so what time for the joke? Just before the end of the period. So around, I don't know. It's hard to say because it depends when I finish with the 40th students. I can't give you a time, I'm sorry. Okay, so for 40th students, now I'm going to put a check mark. Yeah, 11:45 might be a good idea. So around instance of that, okay, that instance of is something we've now covered in the previous unit. And I'm going to put a check mark here beside polymorphism as well. Those are things that we, yeah, sure. Those are things that we covered with where we've got to this point. So we've also now started, and I can start to put a check mark there, that we're started to look at the concept of abstraction and what this means. Now we're going to obviously continue that today. So I feel a little tentative about putting the check mark there right now because we haven't really finished covering that concept yet. But that's where we are. You can see this unit is very close to getting done, even though these last two concepts, three concepts, abstraction, interfaces, and generics, are big concepts. Well, certainly abstraction and generics are. Interfaces, maybe not so big. We'll talk about that when we get there. Okay. So here's the diagram as well of kind of where we're at. And I said to you guys that one of the classes that we had already built, the high school class, could be defined as a abstract class. And if we take a look at the code for high school, we added that modifier keyword into the signature line of the class. This line here is defined as the signature line. It defines the class, that it's going to be a class, that it's going to be public, that it extends student. And now we've added in that this class will be abstract. And what I said that means is it can never be instantiated. So the high school class cannot be turned into a high school object or instance. It can only act as a parent class for other classes, which it does. If you go back to the diagram, you can see that. The high school class is the parent of Husky and Piper. Okay, so we did that. Then the other thing we did, oops, I'm not sharing the screen. Oh, thank you. I will back up a bit here. God, I was on camera. So you just got to see my stupid face for the last few minutes. Okay, let me go back and refresh what I said. So what I said was, I'm now willing to put in check marks beside instance of and abstraction, because we covered instance of. Abstraction, I feel like we're not quite there yet, but I'm going to put a check mark for now. And over here in the vocabulary list, now polymorphism and instance of, and again, I'm very tentative to put that there as well. Okay, but we'll put it there for now. Now, here's the diagram of what we've covered. What I said was this class called high school, which we already have, is going to be defined as an abstract class. So just sharing the code for you with what I meant for that, that high school is an abstract class. Adding this keyword abstract into this line is called the signature line of the class. It's a signature because it defines it as public, as a class, and that it extends student. But by adding the word abstract in there, it means it's a class which cannot be instantiated, which means it can only act as a parent class for the other classes. Okay, so that's what we did there. And then as well, we also said, let's make an abstract class called food. So we did that. And we started defining food as an abstract class. Now, jumping back to this diagram, you can see as well that I also intend to create classes apple and steak, inherit from food, okay? But you'll notice they're not going to be abstract classes. They will not be abstract. They will inherit from food, but they won't be abstract. Now, we're not going to make them yet. We'll make them in a few minutes. We have to finish working on the food class first. Okay, here's what we know about the food class that we started with. The food class is an abstract class representing the concept of food. That's what abstract classes are. They're conceptual. It cannot be instantiated. We already said that. Okay. Once a class has been made into an abstract class, now you can add abstract methods. You can add regular methods, which we're going to do today, and regular properties as well. It's still a class. But what you can add to an abstract class is abstract methods. Abstract methods cannot be added to regular classes. Once you make an abstract method, it must be part of an abstract class. So we made 3 abstract methods. In each of these, we added the keyword abstract. But the other weird thing about abstract methods is they have no method body. They just have a semicolon at the end. Okay? It means that the method has no code, no curly brackets. It ends in a semicolon. However, abstract methods can have parameters. They can return stuff. So those were the 3 methods we made. The first one is just a void method with no parameters called prepare. The second method has a return type, void, and the third method has a parameter, seconds, an integer. We could make a third abstract method that has both a parameter and a return type, but I think you get the point here. So that's what our food class looks like so far. These methods have no implementation. They don't have any body to them. You just create them as concepts. Now, this will come into play later, but we got to now finish a little more work on our food class. So the other thing we're going to do with our food class is we're going to create some properties for our food class. So the first property we're going to make is something we've already done, public property, but we're going to make it a static property, a final, also a constant. So all of these words act as modifiers. They're modifying what I'm about to create. I'm going to create a string. And just by the name of it alone, you know a little thing about it. It is a constant, just based on the name. The S at the end implies something, and that's because I'm about to turn it into an array. It's an array of string objects made constant, made public in this class, and I share it with the class, with all the objects as well. So what are the food groups? Well, there's fruits and vegetables. That's one of the food groups. There's dairy. These are food groups because we're making an abstract food class. There's grains, and we'll make one just called is just a property of this class. It's just a regular, it's not a method, it's a property. Now let's make another property. Hello.
You put the square brackets after the name of the variable. Why isn't that causing an error? Shouldn't it be after data type?
In Java, you can put them there or there. That's possible in Java to do that. Okay. And other languages, you have to put them specifically with the data type, and others there. So that's a good question. Java provides you the option of putting it in either place. In Java, it considers this a modifier as well. So like each of these are modifiers. This makes it public, this makes it static, this makes it a constant, this is the data type, and this makes it an array. Then this is the name, right? So let's compare that with a simpler property, just a public Boolean called eatable or edible. This is not an array, so I'm not bothering with this. I still have the data type. So here's the data type. Okay. Like the other one, it's also public, but I don't need it to be shared, and I don't need it to be a constant. So, and this is just a regular Boolean variable, a simple yes, no, true, false variable. Okay, so that's an excellent point, right? The modifier words end up modifying things about the identifier name. Let's make another one. This one, though, we're going to modify to private, an integer for which group of the various food groups this food item is in. And then one more, we'll make this one, actually, let's make this one, right, we'll make this one private. And this one we'll make protected. It'll be a string for what flavor this food is. Take this food to Flavor Town. So these will be our 4 properties of this class. This one, this one, this one, and this one. 4 properties of this class. 2 of them are public. 1 of them is private, and 1 of them is protected. Okay? We have an integer, a Boolean, and a string. We have a string array, and we have one of our properties being a constant and being static. So these are all fancy words that are modifying our properties, essentially our variables within this class. Okay? So let me add a few comments to this. Okay, and again, I'm going to cheat a little bit. That the first property is the various food groups. Slot 0 is fruits and vegetables up to slot 4 or index 4, which is other. Eatable, right? Whether or not this food item can be eaten or not. The food group, okay? It is a food group, but let's remember that this particular property is encapsulated, which means inside it's an encapsulated property. Which food group this item is a part of. It's encapsulated, it's private. And then flavor, which we made protected, okay, is available to the class and children of the class. That's what protected means, okay? So that's just a review of some of those things we've learned in this unit, how we learned about static, okay? And maybe I'll add that this is a shared constant array. That's what it is. It's a shared array. That's what static means. It's constant and it's an array. This one is protected, so it's available to the class and children of the class. This one is encapsulated, so I can't use it outside the class. And this one is public, so I can use it. So that's just a reminder of those things. All right, let's take a look at the food constructor. Let's add 2 properties to it. Which group? Because group is private, group is private, I'm going to have to pass that into the class. Set this dot group. The other ones I will be able to access. I will be able to access flavor because children of the class can access a protected property. I will be able to access this one because it's public. And I'll even be able to access these ones because they're also public. But flavor, because it's, or pardon me, group, because it's encapsulated, I'm going to access it through the constructor. Through the constructor, I will assign that parameter group to the property called group. And we've talked about that before as well. So there's our food constructor. Then we have our 3 abstract methods, which is fine. But you can place regular methods in a class as well, okay? So we're going to create a regular old method. Public string eat. That's something you do with food. You eat it. So this is going to be a regular method, okay? Not a special method. And I'm going to cheat and put in the comment just to show you how this method's going to go. This method will define how you eat this food object. A little note on this, abstract classes can also, I'll put that, have regular methods and regular properties, which we already did. Not just abstract methods. So they can still have regular methods. Okay, so let's define this method eat. So the way I'm going to define it is if the food has spoiled. So if the food has spoiled, I'm going to return the words do not eat. Because we shouldn't eat spoiled. Otherwise, okay, I'm going to prepare my food. Okay? And when I'm preparing it, this is a call to the abstract method. Food is prepared differently in each specific food item. So I'm abstractly saying I will prepare the food, okay? And then I will return the group, group plus the words it was, and then the flavor. So that's what will be returned when I eat it. So it'll say something like, you know, meats, that was say that what's in that group? Meats. It was, you know, whatever you'd say for meats, right? Delicious. So that's how we will prepare, or sorry, eat our food. This will complete the food class, the food abstract class. It has 1, 2, 3, 4 regular properties, a regular constructor, a regular method called eat, and then 1, 2, 3 abstract methods, as it is an abstract class. So I'm going to take a second to put that up on GitHub. Okay. Git commit. Git vote. Push to 40s into the master branch. Doing a speaker check. So for those of you following in 40s and maybe didn't have a chance to get to those comments, from GitHub now, if you go into the source folder, into testing, and into advanced classes, you should now be able to find the food class, and you should be able to copy and paste any of those comments or those particular items that maybe you might have missed. Okay, so they're all there now. But now what we're going to do is we're now going to create Apple class and the steak class, which will inherit from the food class. Okay, also, as we do that, you'll notice as well that apple and food, or pardon me, apple and steak are going to be used by another class. If I trace this line back to where they're going to be used by, they're actually going to be used by the person class. The person class will be using apple and steak. So we're going to make those connections there. All right, so let's start by right here in your project folder, in your project package, right-click new class Apple. Right-click new Java class, capital A, Apple. We'll do steak in a minute if we have time. For Apple, what I want you guys to do is you can go ahead and delete toString, clone, and equals. We're not going to need those. We will need the constructor, so you might as well leave that one there. Constructor's fine, okay? Now, I'm going to cheat a little, and I'm going to put in the comment here to explain what's about to go on in this class. So the Apple class obviously represents an apple. However, we're about to make this class inherit from or extend the food class. Now, food is an abstract class. So I can use it as a parent object, no problem. So Apple will inherit all the properties and methods of this food class. So it'll inherit this public property, it'll inherit this public property, It won't inherit this because it's private, but it will inherit this because it's protected. It'll inherit this method called eat. But what about the abstract methods? Does it inherit those? Yes, it does. But abstract methods, it will force you to override them. So you'll notice, as I said, extended food, a little light bulb appeared and a little red underline here. And what it will force you to do is it will force you to, I can't zoom in on it, but you can maybe read it there, implement all the abstract methods. This is a good thing. This is what we want to have happen with the use of abstract methods. It's like creating a template that forces you, when you inherit from it, to write these methods in. Now, some terminology from that. We're essentially moving from an abstract concept to a concrete concept. So now the methods must be given a method body. So anyways, let's click that light bulb, implement the abstract methods, and now you'll see them put in here. And now they no longer have a semicolon at the end. Now they have their curly brackets. So now it's going to force you, as it says here, to write a method body. You now have defined how to write that method. But it's now particular. It's for this specific food item. Okay? Now we can also still override regular methods as well. Well, let's start slowly going through the Apple class now and filling in these blanks. Let's start with the constructor. To build an apple, I'm going to make a call to the super constructor, which is food. And I'm going to define which group it is. It's group 0. And I'm also going to go to the super constructor and set eatable, or not eatable, set flavor to be, what will the flavor of an apple be? How about sweet? I'm going to define the flavor of an apple to be sweet. And that's how I'm going to use the apple constructor. Okay. One, I call out super constructor, which is the constructor inside of food, right? This one right here. And I pass the group that I just said. So apples are in group 0. If, by the way, if I didn't kind of remember that, if I had so much code, I could do this, food.groups, because this is a shared array, and I could read my documentation and go, oh yeah, apples are in fruits and vegetables. So that just gives me the ability to do that. And here I'm modifying, okay, another word we've learned in this unit. We could have written a modifier method, but that maybe was going a little too far. Our protected property. Modifying that. All right, let's talk about how we prepare an apple. For this, I'm just going to do an output, a simple output. And I think you should, my grandma always used to say, you should wash your apples before you eat them, because there could be bugs on there and they spray pesticides on them and stuff like that. So that's how I'm going to prepare my apple. Has it spoiled? Well, I'm going to return super.eatable. That's the property you might remember in the food class, eatable, that we made public. So we access, again, another word we've learned students, our public property here, eatable. And finally, for smelling food. For this, I'm actually going to write a little bit of logic. I'm going to say if seconds is greater than, say, 3. If you smell an apple for more than 3 seconds, I'm going to make this thing no longer eatable. Super.eatable. Otherwise, I'm going to make super.eatable into true. If you're smelling an apple for more than 3 seconds, I think that apple might have turned. Now, I decided to skip the curly brackets, but you certainly could put them in if you feel that isn't good code and you'd rather put in those curly brackets. Of course, I accept that. For those of you who still enjoy the C# style, you could even do that. right, for your smell method. But I'm just trying to save space here. So that's what I was doing here, just quickly trying to save space on the smell method. So now we've defined our 3 abstract methods for apple have been properly defined, okay? All right, now I'm also going to take a second to override the eat method. Now the eat method is not abstract, so it's not going to force me to override this method. It's a regular method. Methods that are abstract, we are forced to override them. But I have the option of overriding the eat method. And then it will also say maybe you should put in this override annotation, which was automatically done with abstract methods. So eat method, all I'm going to do is return the words apple from, and then I'm going to go to the super class and call its eat method. So I can use the eat method that I already wrote here, like do not eat, and it was from this, but I'm just tacking onto this the fact that it's an apple from this. So there I have finished the apple class. This is what the apple class is going to look like, okay? Let me put in a few of the comments. To be honest, you can cheat a little bit on these comments, because if you have the comments in the food class, you can just copy and paste them over here. It's kind of unfortunate as well that sometimes the comments don't carry over. I actually always wish that the NetBeans would do that. It would be a lot handier to do that. And then smell, right? I'm going to put in the comment for that. And eat, I'm going to put in the comment for that. So there is our apple class, all done up. Let's go to our testing class and let's build an apple. Apple equals new apple. So we now have an apple, okay? We've built it. Let's smell it. Apple dot, say, smell it for 2 seconds. So that's what I'm doing here. I built an apple and I smelled it for 2 seconds. When it calls this method, it will set this and this, but I'm not eating it yet. I'm not going to eat it yet. Not yet. Let's take a second to build our steak class. This won't take long, trust me. Right click, new Java class. Steak. S. Doesn't matter how you spell it, but that's how you spell it. Finish. My advice for the steak class, go ahead and delete all the methods, including the constructor for steak. Why? Because it's going to be very similar to apple. So what I'm going to recommend we do is go to the apple class and copy all the methods, including the constructor, including the apple constructor, copy all the methods from apple, put them into steak, and then let's just change them up. This will be steak. For a steak, let's smell it a little longer. Let's make it 5 seconds. If you're smelling a steak, because steaks smell delicious to me. So I'm going to smell it but if I'm smelling it for more than 5 seconds, I don't think it's edible. And I'm going to change even my comments a little bit here to steak. And I'm going to prepare my steak by grilling it on the barbecue. It's kind of a fun thought for this long weekend. Prepares the steak. Okay. For my constructor, this is now a steak constructor. And the steak extends food. And since I've already taken care of all the abstract methods, okay, now I've got the steak class essentially done, although it doesn't come from this food group, it comes from food group 1, because food group 1 is meats. And I'm going to describe this, the flavor of steak. I don't know, savory. That's a way to describe this, the flavor of my steak. So, as I said, steak was going to be easy, okay? Because we basically copied and pasted the code from the Apple class, just so we have two different objects here. Obviously, if you were making a formal project, this would be a little more complicated. Let's also go to our testing class and create a steak object, steak. Make sure you import it. And smell for 3 seconds. Finally, what we're going to do to connect this in is we're going to go to our person class. So let's now open up the person class, the class we started this unit with. And let's scroll to the bottom past all the code we have, and we're going to add a method to the person class. Okay? The method is going to be public void, and it's just going to be consume is going to be the name of our method, but it does have a parameter. We consume a food object. Okay? Abstract food object. And all we're going to do is a system out. We're going to say the name of this person is eating, and we're going to attach dot eat. We're going to call the food dot eat method of this consume class, or consume method, pardon me. So any person object can now consume food. Well, okay, let's wrap up today by doing some eating. Let's have our husky eat apple. Sorry, not eat. Consume an apple. And let's have Mr. Walks consume a steak. So this is us in our testing class using the method that's in the person class, which was inherited by all the children of the person class. So that included student, which included high school, which included husky, which included teacher, which included Mr. Walks. So all of those children inherited the consume method. The consume method uses an abstract food item. Through polymorphism, an apple is a food item. That's polymorphism, like we did in the meeting class. So you're starting to see all of the concepts of this advanced classes unit starting to combine here. Well, let's run it and see. Can I create an apple, create a steak, and consume them? Well, I would be able to consume them, but it says do not eat. Okay. Oh, why? Well, remember the way we define smell isn't defined in our abstract class, but it's defined in our apple class. That if we smell an apple for more than 3 seconds, then it's not edible. Ugh. So, oh, I better only smell it for 1 second. See if that makes a difference. Oh, what? What did I do there? Did I screw up something? I might have screwed something up here.
Is eatable default false?
I know what I did wrong. If it has spoiled, do not eat. Has spoiled returns true based on smell, right? And spoiled. Sorry, what did you say? I've kind of lost my train of thought here. I'm just going to switch this. Okay. And I just want to see if the apple. Yeah, there we go. And I'm going to switch it in the state class as well from false to true. My apologies. I kind of got I don't want to take too much more time up here. I want to reverse these logic here, and then there we go. So I wash my apple. Havoc the husky is eating an apple from fruits to vegetable, and it was sweet. And Mr. Walks is eating a steak from meats, and it was savory. I grilled it on a barbecue. Okay, what a great way, I think, to end the example here. I absolutely will put this up on GitHub, and I've been recording this class, so if you missed any of that, I will switch it up. My apologies for that last second change in the code, but don't worry, I'll get it all fixed up. That will absolutely complete our look at abstraction, and we will now move into next week looking at our final two concepts, interfaces and generics. Which means I don't think we'll need the week to do it, okay, which is, I think, a good thing. My apologies, I definitely went over my time there, so we're almost at the end of the class. Thank you for your presence today at my class. I'm just going to stop the screen share as it is the end of the class now. And you may want to throw it up in chat to the 30th students who might still be there, that I now, in a moment, will be putting out the bad joke of the week. Yeah, it's time. Let me just take a sip of my cold coffee here. Another good, another Jets game tonight. I didn't feel good about the Jets this year, but they managed to pull out that first win, but it's going to be tough tonight. Edmonton's going to come back hard at them. For those of you who don't care, you don't care. It's going to be a rainy weekend, but interspersed. So have a nice weekend, everybody. And now it's time for the bad joke of the week. Remember, bad jokes of the week are by definition bad, not funny, not good, neither repeated nor explained. So if you don't like it, you don't hear it, and you don't get it, it's not my fault. You, of course, have this right to accept or reject this over remote learning by disconnecting now and having a great weekend, or muting your speakers. Before I tell it, just a reminder that if you need extra help, or if you need help at all on anything we've been doing, you can see me at 3 o'clock during extra help time on Teams, or you can email me anytime. I'm not sure how much email checking I'll be doing this weekend, but I will do some. So guy goes to the doctor. I know you wanted me to say guy goes to the bar, but guy goes to the doctor and he says, Doc, I've been having a really bad nightmare all week, the same nightmare every night. Doctor says, oh, really? Well, describe it to me. He says, well, when I go to sleep, I have a dream that I'm the muffler of a giant muscle car. That I dream every night. I go to sleep. I dream I'm a muffler. Next night, I go to sleep. I have this dream I'm a muffler. Every night, I go to sleep and I have a dream that I'm a muffler on a car. Doctor says, oh, yeah, that's a weird nightmare. But what's the problem? He says, when I wake up, I'm exhausted. All right, everybody, have a good weekend. I'm going to turn off the recording now. Have a great weekend, everybody.